All right, let's talk AI architecture. When we dive into building AI, it's so easy to get obsessed with finding that one perfect algorithm, right? That single magic tool that's going to solve everything. But that's not how it works, not in the real world anyway. The best AI architects, they're not just amazing coders, they are masters of the trade-off. It's all about making a series of really tough strategic calls that honestly make or break a project. And if you think I'm being dramatic, just look at this. This number is staggering. 80%. 80% of machine learning models start to get worse. They start degrading the very first month they're live. The clock is ticking from day one. So this isn't some what-if scenario, it's a when. If you don't build your system expecting this to happen, you're pretty much setting yourself up to fail. So that brings us right to the architect's core dilemma. It's this constant balancing act, way beyond just writing code. So to really get our heads around this, we're going to walk through the four biggest, most critical decision points you'll face. And let's start where it all begins, the foundation. Your data foundation. Look, every single AI model is built on data. It's the fuel. But right out of the gate, you slam into this huge trade-off. You've got this hungry model that needs tons and tons of data to learn, but at the same time, you have this absolutely sacred duty to protect your users' privacy. And this is the big question, isn't it? It's the puzzle every single one of us has to solve. We need all this rich, messy, real-world data to make a model that's actually useful. But then we also have this huge legal and, frankly, ethical wall we can't cross. We have to protect people's information. So what do? How do you have your cake and eat it too? Well, here's what happens if you get it wrong. It's a disaster either way. If you starve your model, not enough data, you end up with something that's totally biased and just falls apart on any tricky edge case. Basically, it's useless. But if you swing the other way and get reckless with sensitive data, oh man, you're looking at a legal and PR catastrophe. Okay, so one really powerful solution on the need more data side is, what if you could just invent it? That's synthetic data generation. Let's stick with the self-driving car example. You can't just drive around hoping for a freak hailstorm at dusk, right? That could take forever. So instead, you simulate it. You create thousands of variations of that exact scenario in a virtual world. The model gets all the training it needs for those rare edge cases, and not a single real person's data is ever touched. And for the other side of the coin, protecting privacy, we have this amazing technique called differential privacy. The concept is actually kind of brilliant. You inject a very specific, mathematically calculated amount of statistical noise into the dataset. It's like making sure every person's data is hidden in a crowd. It becomes mathematically impossible to reverse engineer the model and say, aha, John Smith's data was in here. It's not just a promise of privacy, it's a mathematical guarantee. All right, next up, the retrieval engine. This is the brain behind the scenes in any modern Q&A system, especially with RAG, that's retrieval augmented generation. It's the part that goes and finds the right documents to answer your question. And here, we had another classic tug of war, speed versus accuracy. I mean, just think about what you expect when you use a search bar. You ask a question, and you want the perfect answer, like right now, not in a few seconds, instantly. Getting both of those things, perfect relevance and zero lag at the same time, that is a monster of a challenge for any architect. Because here's the trap. If your retrieval is slow, even by a second, it completely kills the user experience. The whole thing just feels clunky and broken. But if it's super fast but the answer's wrong or just kind of close, if it misses a key product name or a specific term because it's only getting the general vibe of your query, well then it's totally worthless, isn't it? So to nail accuracy, architects are increasingly using what's called hybrid search. This is a best of both worlds approach. You're not choosing between two different types of search, you're blending them. You use vector search to understand the context and the meaning behind what the user is asking, but you also use classic keyword search to make sure you hit on those exact specific terms. It's powerful, for sure, but yeah, it definitely makes the system more complex. Now for speed. This is where architects get really aggressive. We're talking about squeezing every last millisecond out of the system. You're fine-tuning index structures, maybe shrinking down the size of your embeddings. And then there's a big one, quantization. That's basically like taking a super high-res image and saving it as a slightly smaller file. You're making the numbers that represent your data less precise, which makes everything way smaller and faster. Each one of these is its own little trade-off, all in the name of speed. Okay, so we've got our data and our retrieval engine. Now we need to actually make it all work together automatically. This is the automation backbone, your MLOps. And it brings up a really cool debate. Do you want a super structured, predictable system, or do you want something more flexible, more autonomous? Because let's be real, we've all been there. The system is held together by a bunch of fragile scripts that one person wrote 3 years ago. You know that one script that only Dave knows how to run? That doesn't scale. The real goal is to move from that world to something truly robust, workflows that are smart enough to handle real-world messiness without needing a human to babysit them 24/7. On the structured side, you have titans like Apache Airflow. The best way to think about Airflow is like a very, very detailed recipe or blueprint. You define every single step, what depends on what, and when it all runs. It's perfect for those predictable, repeatable tasks, like your daily data processing or a weekly model retraining job. The whole point is reliability. You know exactly what's going to happen. But then you have the completely different philosophy of agents, powered by frameworks like LangChain. So if Airflow is the detailed blueprint, an agent is more like a super smart intern. You don't give it a step-by-step plan, you give it a goal and a toolbox. You say, hey, this data is a mess, clean it up, and the agent figures out how to do it by using the tools you gave it. This is all about handling the unpredictable, all about flexibility. Okay, let's get to our last trade-off. And honestly, this might be the most important one, the one that really keeps architects up at night. This is all about what happens after your beautiful system goes live. It's the fight between just noticing your model is dying and actually building a system that can do something about it. And this chart, this is the harsh truth. Every single model you put into production will face this. The world just doesn't stand still. New trends pop up, customer behavior changes, and the data you trained on gets stale, fast. So your model's accuracy doesn't just dip a little, it nosedives. And the worst part? It's a silent killer. If you aren't actively monitoring for it, you won't know it's happening until it's already causing huge problems. So the answer is to build an immune system for your AI, a living, adaptive system that fixes itself. It's a closed loop, completely automated. Step 1, you use tools to constantly detect if the data is drifting. As soon as performance drops below a certain line, bam, an alert goes off. That alert doesn't just email a person, it automatically triggers a brand new retraining job, and once that new model is ready and validated, it gets deployed automatically. The system literally heals itself without anyone lifting a finger. And really, that's what this all boils down to. This is the big idea. Being a top-tier AI architect today, it's not about being the best coder in the room. It's about being a master strategist. It's about deeply understanding these fundamental tugs of war, data versus privacy, speed versus accuracy, structured blueprints versus autonomous agents, and decay versus adaptation. It's about navigating these choices to build systems that don't just launch successfully, but actually last. So I want to leave you with a question to chew on. As these AI systems get smarter and more autonomous, and they will, the weight of these decisions gets even heavier. So what's your line in the sand? When push comes to shove, which one of these trade-offs will you absolutely refuse to make? Because your answer to that, that's what's going to shape the future of this technology.